Hello everyone, my name is Kshitijwani and I am an intern of Emertxe Technology. I am presenting home automation using IoT as a project in this internship. So, moving ahead to the content which I have covered in this project. After that, the topics which we learned during this internship. So, basically, we have learned the C programming, whereas the basics of C programming is here, like keywords, basic data types, operators, condition constructors, and looping concepts, arrays, pointed functions, etc. Moving ahead, C++ programming, in which OOPS we have learned about the OOPS. Again, the introduction to IoT, definition of IoT and IoT architecture, the introduction to embedded system, whereas definition and types of embedded system, as well as the components of embedded system. We have learned about the peripherals also. So LED, Arduino Uno, CLCD, and ADC. Also the project requirements. So basically the peripherals required in this project. So some peripherals are LDR sensors, which is used to sense the uh, light. They are the sensors which are used to read the brightness of light. And the temperature system, it consists of heater, cooler, LM35. We can read the temperature from the temperature sensor. Okay, so serial tank, we can read the volume of the water tank through serial communication. Now the IoT introduction. The Internet of Things, IoT, is the network of physical objects that contain embedded technology to communicate and sense or interact with their internal states or the external environment. These devices range from ordinary household objects to sophisticated industrial tools, which more than 7 billion connected IoT devices today. Experts are expecting this number to grow to 10 billion by 2020 and 22 billion by 2025. By means of low cost computing, the cloud, big data analytics, and mobile technology, physical things can share and collect data with minimal human intervention. In this hyper-connected world, digital systems can record, monitor, and adjust each interaction between connected things. The physical world meets the digital world and they cooperate. So, this is the IoT architecture, which have four stages of IoT architecture. This is the embedded system. The embedded system is a combination of hardware and software which is intended to do a specific task. So it has three parts: software, hardware, and framework. Unlike computers, embedded systems perform few specific limited tasks. Embedded device can peripherals Embedded devices have peripherals such as serial communication interface, which is also called a SCI, synchronous serial communication interface, universal serial bus, which is also called USB, multimedia cards, which are SD cards, compact flash, etc. Now the requirements for these projects. So hardware requirements are Arduino Uno, ETH W5500, PCF 8574, temperature sensor LCD HD44780, LTR sensor, and LED. Now the software requirements are Arduino IDE for coding, Pix, PixSimLab for simulation, full modem emulator to configure ports of serial remote tank, Blynk IoT app for cloud server, and Arduino Uno. So Arduino Uno is based on the Atmega 328P microcontroller. It is easy to use compared to other boards such as Arduino Mega board, etc. The board consists of digital and analog input-output pins, shades, and other circuits. The Arduino Uno includes 6 analog pins of inputs, 14 digital pins, a USB connector, a power jack, and ICSP, which is called an in-circuit serial programming header. It is program based on IDE, which stand for Integrated Development Environment. It can run on both online and offline platforms. Now ETH W5500. W5500 chip is a hardware TCP/IP embedded Ethernet controller that provides easier internet connection to embedded system. It enables users to have the internet connectivity in their applications just by using a single chip in which TCP/IP stack 10 to 100 Ethernet MAC and PHY embedded. Supports power down mode, supports wake up on LAN over UDP, supports high speed serial peripheral interface. So this is an W5500 network chip. They have shown the figure. So PFC 8574. The PFC 8574 is a silicon CMOS circuit. It provides general purpose remote input output expansion for most microcontroller families via the two-line bidirectional bus 12C. The device consists of an 8-bit coaxial bidirectional port and N12C bus interface. Temperature sensor. A temperature sensor is an electronic device that measures the temperature of its environment and converts the input data into electronic data to record, monitor, or signal temperature changes. LCD HD44780. So the LCD is a dot matrix liquid crystal display controller and a driver. LSI displays alphanumeric and symbols. It can be configured to drive a dot matrix liquid crystal display under the control of 4 or 8-bit microprocessor. Uh, Now LDR sensor. LDR is a component that has a variable resistance that changes with light intensity that falls upon it. This allows them to be used in light sensing circuits. Resistance of a resistor decreases with increasing incident light intensity. In other words, it exhibits photoconductivity. Now, step 1 is loading the hex file. Now, showing in this figure, we are seeing that we are loading this hex file in the software. Now, when the LDR is high, then the LED will be on. And when the LDR is low, then the LED will be off. Now again, cooler. When the cooler is on, okay, this is showing the cooler on and this is showing the cooler is off. Also the heater is on and here the heater is off. Now the inlet wave is on and the inlet wave is off, like that outlet wave. So the note in this Blynk app, the notification of heater temperature is shown just like this. And here the heater will automatically turn off when the temperature rises about 35 degree. Now the notification of water level is here. The water tank is full, the inlet will automatically turn off. Now water volume level is given here.
So this is the Arduino IDE which I was talking about, where we have different IONO files, CPP files, and H files to code our project. So IONO file will be the main file that we will be executing, and through Sketch we will be exporting the compiled binary, which will be uploading as a hex file in the PiximLab. So let me go to the PiximLab. So this is the PiximLab. Here we have chosen an Arduino Uno board, which we'll be using for the project. So this is the PiximLab spare parts, where we can see all the arrangements of the parts that we are using in our project. This indicates an LCD display. So this is the LED that we are having. So this is an LDR, and this is the cooler, or we can say a temperature system, and this is the Ethernet which provides connection, so we can turn off or turn on the system. So these are the main components of the projects that we are going to use. We restart the Arduino. This is the button to restart. As you can see, all the values came to null, or there is no display of the values of the temperature and volume. As I told, we are gonna use Blynk IoT app for the automation usage through Android phone. So let me mirror my phone to you. Yeah, you can see the display of my phone here. So let me go through this Blynk IoT app. Here you can see the home automation app that we have created. As I told, we have different widgets like cooler, heater. This is a temperature sensor, and we have two tabs. Tab 2 where we have inlet valve, outlet valve, and a water volume indicator. So you can create all these widget buttons and these notifications and all using settings, where you will get an option to select the widgets like buttons, slider, vertical slider, or gauge, etc. Let me on the Ethernet first, so that we can have a connection to the project and to our app. So first we will look into our temperature control system. Here we have a cooler button, a heater button to control the temperature. So if I just switch on the heater button, so the temperature increases, which we can see on both LCD display as well as in our phone. As soon as the temperature goes above 35 degrees Celsius, the heater automatically turns off. So this is one of the objective of our project, and this notification we can see in here, temperature is above 35 degrees Celsius, hence the turning off heater. So similarly, when the heater turns off automatically, the temperature gradually reduces. As you can see, it is reducing by a small factor. So if you want to reduce the temperature automatically to some large values, so you can turn on the cooler, which reduces the temperature very quickly. Next, we will look into the water tank system, that is in tab 2. So we will use a serial remote tank for the display of the water tank. So here the inlet valve is off, the same value we can see here that the inlet valve is off and the volume is 2130 liters, which is same we can see over here, 2130 liters. So when I turn on the inlet valve, the amount of volume increase of water increases in the tank, which we can see the readings over here as well as the gauge or as well as here in LCD. So when it reaches the 3000, the inlet valve automatically turned off, which is the second objective of our project, where it says when the volume of the water in the tank fills up or it is complete, the inlet valve should automatically turn off so that there is no overflow of water. So this we can also see in the notification, which indicates that the tank is full, hence disabling the inlet valve. Now let's see turning on the outlet valve what will happen. So I have switched on the outlet valve, so you can see the water volume is decreasing, and as soon as it reaches 2000 liter, as you can see it is decreasing, yeah, as soon as it reached 2000 liters and going below it, the inlet valve automatically turns on so that there will be no less water available in the tank for the usage. So the same we can see in the notification when the volume is less than 2000 liters, enabling the inlet valve.
So the conclusion is using Blink lot application and Peak SimLab simulator simulated home automated automation where LED temperature system serial tank resembles light heater, cooler and water tank in real time. CLCD acts like a dashboard used for displaying the events. Widgets from Blynk IoT app like button widgets are used to control header, cooler and inlet wave, outlet wave. Gauge widgets to display the temperature and volume of the water. Thank you.